Our planet has a long and fascinating history stretching back billions of years. It is a story told in the rocks, a chronicle of ancient seas, dramatic volcanic eruptions, and the slow, relentless march of evolution. One chapter in this epic saga stands out with particular significance: the Cambrian explosion. This period, beginning around 541 million years ago, witnessed an unprecedented explosion of life, a biological revolution that shaped the destiny of life on Earth. Imagine a world devoid of familiar animals, a world where the oceans teemed with strange and alien creatures. This was the Cambrian, a time of profound evolutionary experimentation. In a relatively short period, perhaps as little as 20 million years, life underwent a remarkable transformation. Simple, single-celled organisms gave way to a dazzling array of complex, multicellular animals. The Cambrian explosion is a pivotal event in the history of life. It marks a turning point, the moment when the tapestry of life as we know it began to be woven. Before this time, life was largely restricted to microscopic organisms and simple, soft-bodied creatures. However, the Cambrian witnessed the emergence of most major animal phyla, the fundamental blueprints for animal body plans. This period is not just of interest to paleontologists and evolutionary biologists. It holds profound implications for our understanding of life itself. The Cambrian explosion raises fundamental questions about the pace of evolution, the role of environmental change, and the very nature of biological innovation. It is a time capsule that offers us a glimpse into the distant past, a time when the stage was set for the evolution of all the incredible diversity we see around us today. To truly appreciate the magnitude of the Cambrian explosion, we must first journey back to the Precambrian, the vast expanse of time that preceded it. The Precambrian encompasses the majority of Earth's history, from its formation around 4.6 billion years ago to the dawn of the Cambrian. Life first emerged in the Precambrian, around 3.5 billion years ago. These early life forms were incredibly simple, single-celled organisms, similar to bacteria. For billions of years, these microscopic pioneers were the sole inhabitants of Earth. They played a crucial role in shaping the planet, gradually transforming the atmosphere and oceans. Evidence suggests that multicellular life may have also emerged during the late Precambrian, though these early organisms were relatively simple and left a limited fossil record. One intriguing example is the Ediacaran biota, a collection of enigmatic, soft-bodied creatures that thrived in the shallow seas around 600 million years ago. However, the Precambrian world was a far cry from the vibrant, bustling ecosystems we see today. Life was still in its infancy, constrained by its simplicity and the harsh environmental conditions. The oceans were vast and largely empty, lacking the intricate food webs and complex interactions that would characterize later eras. The Precambrian was a time of slow, gradual change, a period of biological incubation. Life was poised on the brink of a revolution, awaiting the right combination of environmental factors to unleash its full potential. Around 541 million years ago, a dramatic shift occurred, marking the beginning of the Cambrian period and ushering in a new era in the history of life. The precise triggers for this dramatic change, this sudden burst of evolution, are still debated by scientists. One possibility is that rising oxygen levels in the atmosphere and oceans played a key role. Oxygen is essential for the metabolism of most complex life forms. Increased oxygen levels would have provided the fuel for larger, more active animals. Changes in ocean chemistry, perhaps an increase in the availability of nutrients, may have also contributed. These changes could have created more favorable conditions for a wider range of organisms, spurring diversification. Whatever the trigger, the Cambrian explosion saw an unprecedented surge in evolutionary innovation. New body plans appeared with astonishing rapidity. Organisms developed novel ways of moving, feeding, and interacting with their environment. This period saw the emergence of the ancestors of most major animal groups we know today. From the segmented bodies of arthropods to the hard shells of mollusks, The basic blueprints for animal life were laid down during this remarkable period. The Cambrian explosion was a time of unparalleled creativity and experimentation in the history of life on Earth. Section 4. Trilobites and arthropods, pioneers of the Cambrian seas. Amongst the most iconic and abundant creatures of the Cambrian were the trilobites. These fascinating creatures, now extinct, belong to a group known as arthropods, which includes modern-day insects, spiders, and crustaceans. Trilobites were highly successful, inhabiting a wide range of marine environments. Their name trilobite, meaning three lobes, refers to the three distinct longitudinal sections of their bodies. These creatures possessed a hard exoskeleton, a tough outer shell that provided protection from predators and support for their bodies. This exoskeleton also served as a site for muscle attachment, allowing for greater mobility. Trilobites exhibited a remarkable diversity in size and form. Some were small, only a few millimeters long, while others grew to over 70 centimeters in length. They developed a variety of adaptations for different lifestyles. Some were predators, equipped with powerful claws, while others were scavengers or filter feeders. The success of trilobites and other early arthropods highlights a key feature of the Cambrian explosion: the evolution of hard body parts. These structures provided numerous advantages, including protection, support, and the ability to exploit new ecological niches. The fossil record of trilobites is incredibly rich, providing paleontologists with a detailed window into the evolution of early animals. Their abundance, diversity, and well-preserved exoskeletons make them ideal index fossils, helping scientists to date and correlate rock layers across different regions. Section 5. The rise of multicellularity, a profound transition. The Cambrian explosion wasn't just about the diversification of animal life, it was also about a fundamental shift in the way life itself was organized. Before this period, life was primarily unicellular, consisting of single-celled organisms. The Cambrian witnessed the rise of multicellularity, a profound evolutionary transition that paved the way for the evolution of complex organisms. Multicellularity, as the name suggests, refers to organisms composed of multiple cells. This arrangement allows for specialization, with different cells performing different functions. This division of labor enabled the development of tissues, organs, and complex body plans. The exact mechanisms by which multicellularity arose are still being unraveled. One possibility is that single-celled organisms began to cooperate, forming colonies. Over time, these colonies may have become more integrated, with cells becoming increasingly specialized. The evolution of multicellularity had profound implications for life on Earth. It allowed for an increase in size and complexity, opening up new evolutionary possibilities. Multicellular organisms could exploit a wider range of resources and habitats, leading to the diversification of life forms we see today. The emergence of multicellularity during the Cambrian explosion was a pivotal event, marking a turning point in the history of life. It set the stage for the evolution of all complex organisms, from fungi and plants to animals. Section 6. The emergence of new forms and adaptations. The Cambrian explosion was a period of remarkable experimentation, a time when natural selection favored the evolution of novel features and adaptations. The fossil record from this time is replete with bizarre and wonderful creatures, showcasing the incredible diversity of life that flourished during this era. One of the most significant developments was the evolution of the exoskeleton, a hard outer shell that provided both protection and support. As we've seen with trilobites, this innovation allowed animals to grow larger and more complex. It also provided a platform for the evolution of appendages such as legs and antennae, which enabled greater mobility and sensory perception. Another key adaptation was the development of eyes. While some simple light-sensitive organs may have existed in the pre-Cambrian, the Cambrian witnessed the evolution of complex eyes, capable of forming images. This innovation revolutionized the way animals interacted with their environment, allowing for more sophisticated predation and predator avoidance. the Cambrian also saw the emergence of diverse feeding strategies. Some animals, such as the filter-feeding sponges, developed ways to extract nutrients directly from the water. Others, such as the predatory Anomalocaris, possessed grasping appendages and sharp mouthparts for capturing prey. This period also witnessed the evolution of biomineralization, the process by which organisms incorporate minerals into their bodies. This innovation led to the development of shells, skeletons, and other hard tissues, providing both protection and structural support. Section 7. Predators and Prey, the Cambrian Arms Race. The Cambrian explosion wasn't just a peaceful blossoming of life, it was also a time of intense competition and predation. As new forms evolved, so too did new ways of hunting and hiding. This period witnessed the beginning of what evolutionary biologists call an arms race between predators and prey, a dynamic interplay that would shape the course of evolution for millennia to come. With the evolution of eyes and more sophisticated nervous systems, predators gained a significant advantage. Creatures like Anomalocaris, with its large compound eyes and formidable grasping appendages, became apex predators, terrorizing the Cambrian seas. In response to this predatory pressure, prey animals evolved a variety of defense mechanisms. Some developed hard shells or spines for protection. Others evolved camouflage, blending in with their surroundings to avoid detection. Still others developed speed and agility, allowing them to outmaneuver their attackers. This constant interplay between predator and prey fueled evolutionary innovation, driving the development of new adaptations and counter-adaptations. The Cambrian explosion was a time of rapid ecological change, as new species emerged and competed for resources, constantly reshaping the balance of power within these ancient ecosystems. The ecological interactions that emerged during the Cambrian explosion had a profound impact on the trajectory of life. They led to the establishment of complex food webs, with intricate relationships between predators, prey, and their environment. This dynamic interplay continues to shape the natural world we see today, driving the evolution of new adaptations and ensuring the survival of the fittest.